All right. The last time we were together on Thursday, we looked at this graph.
Yes, we did.
Yes, we did, but that was a while ago. So can I have your eyeballs up on the board right now, Christopher? Okay. So we had somebody, robots or something, making something, and they had to buy parts, and then they sold what they made. And we looked at two functions, income and cost, and one key feature we talked about is this break-even point. Both of those functions have their own linear equation, but the break-even point is where they are equal. And it was important in this scenario that after that break-even is where income started to get higher than cost. You're going to make a profit. But the break-even point is where the two functions meet. Okay? One thing we looked at the very end of Thursday, but we didn't do a whole lot with, and is how could we find that break-even point algebraically? So we have the two functions, and they were turned into y's and x's. We had them both in y equals form, and then because they were both equal to y, we took the two pieces and set them equal to each other. Okay, so this top pink is right here. This bottom pink is right here. And then setting them equal to each other, we were able to find an x. All right, we're going to be doing this kind of thing with other equations right now, but notice it's in y equal form. Set the two functions equal to each other, solve for x. That's where this paper comes in. Here's a bunch of examples. Take number 1 and write it on your separate paper. I'm going to call this systems of equations. Now, a system of equation is anytime you have more than one. For number 1, they give us two fairly small ones. Okay, what we're really doing with, Guillermo, can you put down, please, and do what we're doing? What we're really doing with these is we're finding the spot where the two functions match. Where are they the same? In our robot scenario, it's where the income and cost were equal. Right here, we're going to do something similar. We're going to take this side of the equation and set it on one side of an equal. And in the second equation, this little piece of our expression on this side. The reason we can do this is they're both equal to y. This is called substitution. It's kind of like on a team. Who plays basketball? Anybody play basketball here? Okay. Martine, do you play?
Chris.
Any other girls?
Clear.
Imogen. Okay, we've got Imogen and Kenya. All right, are on the same team. Okay. If I have 5 people on the floor and one of them's Kenya, but I want to give her a little rest, I'm going to ask for a substitution, and I'm going to take Kenya out and put Imogen in. That means they both can do the same job, more or less. Okay? They will take over, or we can consider them to be equal. Okay? So you're trading one for the other. Now, this... Yeah.
Can I use the restroom?
I think, is the pass gone?
Both are there.
Okay, go ahead. What we have right here now lets us solve for x. We need to get the x's on one side, numbers on the other. I think I'm going to move this x by adding an x here and adding an x there. This one was a minus x. Now I have a plus x. Those two cancel each other out. And I have 6 now all by itself on one side of the equation. Now one thing to note about a variable with no number is it has an invisible 1. Guillermo, could you write this down? What happens when you add 1 plus 1?
2.
Okay, so 2x. Divide by 2 on both sides. 3. Now, in a system of equation, what you're looking for is that intersection spot, and that has an x and a y value. So this is half of our answer. That's a good spot. Now we go up to one of the two that are up here and substitute that in. Now in this case, it's easy to substitute it in that first one. Y equals x, and if x is 3, that means y equals 3 as well. You will have 2 answers in these, or you can think of them or express it as an ordered pair. 3, 3. 3 for the x and 3 for the y is the intersection of those two functions. Okay? Number 2. Y equals minus x. Y equals x plus 9. Oscar, what's going to be my first step? Well, let's look at the example we just did. Here's our two functions. Here's what we did next. How did we get this? Not yet. Nope.
Subtract.
Nope. How did I get from here two things that are separate to one equation? What do I gotta write?
X equals x plus 9.
Is it x? Okay, wait a minute. Notice I boxed something here. I boxed that x. I found it on one side of the y equals for this one, and I put it over there. Is that what we have right here? No, that's not x. What is that?
Negative x.
I got to put negative x equals. Now I got that negative x right here. What goes on the other side? X plus 9. Because these are both equal to y, it's like this is Kenya, this is Imogen. I can put them both in at the same time. They're both equal to y. All right? That also means that I can show them equal to each other. So I got the x right here, the x plus 9 right there, and the first step is set them equal to each other. What are we going to do next, Donna? Add an x. Are we going to add this x? Now, if we add an x here, that x is going to come over on this side. I really need the 9 by itself. I need to subtract this x. I'm going to do the same thing to both sides. Again, I want numbers on one side, x's on the other. So I got to get rid of this x by adding a negative. Now I have negative 1 plus negative 1. Negative 2x equals 9. What do I got to do with that? Guillermo, what do you think? How did I get from 2x equals 6 to x equals 3? Okay, so what do I need to do here, Guillermo?
Divide.
What am I going to divide by? What did I divide by here?
2.
Okay, is that what I'm going to divide by this time?
Negative 2.
Divide by negative 2, divide by negative 2. Hello?
You come to the office. He's being checked
I
out.
can get it for you.
It's
All right.
Jerry.
Yeah, I can get it to you today. All right, and there is, my grades are on a Google Doc that I shared with you. You know how to get to shared with me? Okay, so I'll just send you the grades. Okay? Old fashioned way, yeah? I have internet. Yeah. We got internet. Okay. All right. Okay, bye. Here we go. Does that divide? No. So x equals -9/2. Hello, gentlemen. I'm going to leave it in fraction form. Now I got to take this up and find y. This is going to be a little trickier this time. Y equals negative of whatever x is. Because up here, y equals -x. This is x. I put it in right here, but I'm knowing that's going to be the opposite of what x is. What happens when you have a negative of a negative or opposite of a negative?
Positive.
Okay, so that's +9/2. If I was looking at the ordered pair for this, the x value is -9/2. The y value is +9/2. All right? Let's see what you guys go ahead, do number 3 at your table, please. Number 3 at your table.
Oh, shoot.
We'll start by writing it down, and then see if we can figure out that second
Is that how
step.
you
Okay, you might need another piece of paper because you're writing very big. Well, that's not going to work very well. That's going to be confusing as it is. So get another piece of paper. Great. Okay, you are using How do you get the 3 by itself? Okay, good. But it's not by itself. How can we get the 3 by itself? Not yet. You're not ready to divide. Subtract it from both sides. Not yet. Divide by -3.
Is that how you guys get x equals 5?
Yeah. So let's see what you get at the end.
And you can go.
Excuse me. Excuse me. We can't both go. No.
I'm leaving.
Excuse me. One of them sits off.
I'm already
Everybody, this guy's next. Alright, so let's see. We have oh, awesome, good. Hold that shot. Awesome, good job.
Then when you get that negative one, you're gonna take it and put it in somewhere. But I'm not sure I need both. So you have this runs out. That's what you have to do. Now you go put T instead of yeah.
So we got. Wait, you're missing a piece. See this negative x? It should have been negative x plus 2. You only circle. You put a box around that and didn't bring down the 2. This step you didn't do correctly. Minus 1 is right. It's not. Back to one of these two. For the x. Second one, right? Instead minus 1. Figure out what y is. Did you guys get good? Not 1. Yes. Now you gotta find y. Go to one of these equations and put negative 1 in where x is. We're on the left. This side.
Why don't we just get the whole thing?
I'd say off.
So Matt, you know why you just basically take this right here.
Hey. Yeah,
Down to get x on one side. Okay, let's take a look at this. Here we go. Guillermo, he's ready. If you want to go. Here we go. If I could have your attention up this way. Most people are close to kind of understanding the steps. Excuse me. First, because they're both equal to y, we can set this piece equal to that piece. Second, we need to move things around to get x's on one side Ernesto, y's on another. I'm going to start by adding an x here. That gets rid of that negative. I'm going to add it to the other side. This is going to be 2 equals. Remember, this x doesn't have a number, but there's an invisible 1. Then I'm going to minus the 5. 3x equals positive 2 plus negative 5 is negative 3. Divide by 3, x equals negative 1. I'm halfway done. I need the x and the y. So after I find x, I go look and say, which of these do I want to use? I think I'm going to use the bottom one because I don't like negatives. So I'm going to go y equals 2, and instead of x, I'm going to replace the x with a negative 1. I'm going to substitute negative 1 plus 5. The plus 5 was part of the equation. The 2 was part of the equation. I'm just using minus 1 to replace the x. Y equals 3. So as an ordered pair, this is negative 1 for the x, 3 for the y. All right? I saw that starting to make sense a tiny bit. Let's see. Go ahead and do number 4, please. Do number 4. What? Yes. Okay. Hold on a minute. Talk at your table, please.